Today we are starting Chapter 4. Chapter 4, Section 1, we're talking about something called congruent figures. So first off, what does congruent mean? Congruent, anybody? What does that mean? Just the word congruent. We talked about that a while ago. Same size, same shape. That's what congruent means. Same size, same shape. So congruent figures or congruent polygons are going to be polygons that have the same size and same shape. It does not matter which way they are turned. They don't have to be facing the same way. For these two triangles up here on the board, they don't have to be both looking like that. Okay? Now I traced this triangle here, and so of course they'd be congruent facing like that, they'd be congruent facing like that, they'd be congruent facing like that. Same size, same shape is what's important, not the way it's turned or facing. Okay? So for congruent figures, same size, same shape. That is what is important. So what do we get with congruent figures? Well, here's our definition. Congruent polygons have congruent corresponding parts. That means they're matching sides and matching angles. Okay? When you name congruent polygons, you must list the corresponding vertices in the same order. List the corresponding vertices in the same order. So looking here, this statement, this is called a congruence statement. Okay? It is saying that quadrilateral ABCD is congruent to quadrilateral EFGH. Okay? But I call this a roadmap. Okay? I call it the roadmap, nickname it the roadmap. And the reason I do that is because this actually tells us all the information we need, just like a roadmap. It's going to tell you how far different cities are, it's going to tell you what roads to take, you can find alternate routes if you need to, all that kind of good stuff. Same thing here. We can find all the information we need about these congruent figures from that statement. Okay? So quickly, what information am I talking about? Well, they talked about those corresponding parts. So if I have quadrilaterals have how many sides? 4. That's why it's called a quadrilateral. Quad means 4. Okay? So we have a quadrilateral, 4 sides. Well, it just so happens that if a polygon has 4 sides, it also has 4 interior angles. So that means we have 8 parts. Okay? We'd have 8 corresponding parts. 4 sides and 4 angles. Okay? Well, what do we get? We get line segment AB is congruent to line segment EF, line segment BC is congruent to line segment FG, and notice where they're getting these from, by the way, looking at the diagram. AB congruent to EF, BC is congruent to FG, CD is congruent to GH, and DA is congruent to HE, those line segments. And then we can go around and talk about the angles. Angle A is congruent to angle E, angle B is congruent to angle F, angle C is congruent to angle G, and angle D is congruent to angle H. And hopefully it's easy for you guys to see that in these two figures, really it's just like they're mirror images of each other. Like think of 2 pieces of bread and we just fold them together to make our sandwich, right? That's how they're mirrored image of each other, so they're the same shape. Okay. But sometimes you're going to get a figure or a pair of figures that it's not so easy to just look at and say, oh, those are the corresponding angles, and oh, those are the corresponding sides. Okay? Sometimes it's not so easy to do that. And so that's where that roadmap comes into play. Because first off, looking at the roadmap, I can immediately see that angle A is congruent to angle E, because they show up in the same spot in that roadmap. I know that angle B is congruent to angle F, again, because they show up in the same spot. Angle C is congruent to angle G, and angle D is congruent to angle F. Okay? That is stated in that congruence statement. The line segments are also stated in the congruent statement. Line segment AB is congruent to line segment EF. Line segment BC is congruent to line segment FG. Right? It's stated right there in the congruent statement, in that roadmap. Line segment CD is congruent to line segment GH. Okay? Now, the last one you got to see here is that AD. Notice where they show up in the congruent statement. AD, line segment AD is congruent to line segment EH. Okay? But again, all the information we need is right there in that roadmap, in that congruence statement. Questions about congruent polygons, or questions about what that congruent statement tells us? No? Doing okay? Making sense? Grunt once for yes, twice for no? Making sense?
Yes.
Okay, all right, all right. Let's take a look at an example. Finding the congruent parts. Many of you in here, if I give you this problem, you're going to attempt to look at the diagrams because they give you the diagrams. You're like, all right, well, what must work here? And you're going to try to turn this thing in your head and all that kind of stuff. Okay? If they give you a congruence statement or a roadmap, I suggest don't even look at the diagram. Look at that statement right up here. That statement tells us everything we need to know. Okay? So ignore the diagram for a moment. Ignore the diagram for a moment. First off, how many sides do we have on these polygons? 4. So therefore, we're going to have how many total corresponding parts? 8. 4 sides and 4 angles. Okay? So looking at that roadmap up there, we can immediately list our 4 congruent angles. All right? Because I know on the first polygon I have angle H, and I have angle I, and I have angle J, and I have angle K. All right, so that's just the first polygon. Now, looking at the roadmap, angle H is congruent to which other angle?
L.
Angle L. I know that because they are in the corresponding positions in the roadmap, right? So what angle is angle I congruent to? Angle M. Angle J is congruent to angle N. And angle K is congruent to angle O. Make sure that you are using the proper notation. Don't just say H is congruent to L. It's angle H congruent to angle L. Okay? Use your proper notation. Next, we need to find line segments. And so again, looking at the roadmap, I see HI. And again, make sure you name it as a line segment. So line segment HI. By the way, line segment HI will be congruent to which other line segment?
LM.
Yeah, line segment LM. And then line segment IJ is next. So in line segment IJ, that's congruent to what? MN. Line segment JK is congruent to line segment NO. And lastly, what's our fourth line segment? Right, HK or KH, right? And by the way, line segments, you can name them both ways. It's the same thing saying KH as HK, all right? It doesn't matter which way those are named. So line segment HK is congruent to line segment LO. All right, questions on finding those 8 pieces of information? No. Well, if they ask me to mark the diagram then, if they ask me to mark the diagram, or if I want to mark a diagram to help me work a problem, I would simply make sure to use the appropriate number of congruency marks. Remember, angles, you get little arcs marking the angle, right? So angle H is congruent to angle L. Angle J is congruent to angle N. Angle I is congruent to angle M. And angle K is congruent to angle O. Okay. Now we look at the line segments. Line segment HI is congruent to line segment LM. So those get just one dash mark. Excuse me. Line segment JK is congruent to line segment NO. Line segment IJ is congruent to line segment MN. And line segment HK is congruent to line segment LO. All right, so if we had to mark the diagram, that is what we should get. Now, does it really matter which one I mark with one dash mark versus two dash marks? No, just as long as you're marking the congruent segments or the congruent angles the same. Okay? And you got to make sure you don't use the same congruency marks for segments or angles that are not congruent. You can't just mark everything with one mark. Okay? Questions on that? No. All right, let's take a look at the next one. The next one, not only are we going to find our congruent sides here, because they're asking us, are these two triangles congruent? Well, right now we only have one way of deciding whether or not these triangles are congruent. We've got to find their congruent corresponding parts. Okay? So if we're dealing with triangles, how many total congruent corresponding parts should we have? 6. Because triangles have 3 sides, and therefore they have 3 interior angles, so there are 6 total corresponding parts. Okay? And so, let's just go through and start marking things that we know. What do we know for sure in this diagram? Do we know anything for sure in this diagram? Yeah, what? Huh? Oh, angle B is congruent to angle D. Cool. What else? Angle A is congruent to angle E. Excellent. What else do we know for sure?
AB is congruent to ED.
What are those?
Segments.
Line segment. So line segment AB is congruent to line segment DE. Excellent. And anything else we know? Is there more information given in the diagram? What information is given? A 4 and a 6. What do you suppose those are indicating? Phone numbers? Addresses? Length, maybe? Yeah, those are giving me length. It's telling me that the length of line segment BC is 4 units. So what do you suppose that's telling me? BC is congruent to line segment CD. They have the same length, therefore they are congruent, so that is our definition of congruent segments. It's our definition of congruent segments. All right. What about another line segment? Do we have another line segment?
Yeah, AC and line segment AC congruent to CE.
Line segment AC is congruent to line segment CE. And again, because they have the same length, so that's the definition of congruent segments. Cool. So we have three sides, three pairs of sides, so we have all the sides we need, but we only have two angles, two pairs of angles. So where can we find that third pair of angles? Do we know any other angles are congruent? For any reason that we may have talked about in chapter 1 and chapter 2 and chapter 3?
BC are congruent?
BC is a line segment.
I mean, I meant like angle B and angle C are
Nope. Nope, nope, nope. Yeah.
Can you just put angle C as congruent to angle C?
Angle C is congruent to angle C, so you're talking about this angle C up here and this angle C down there? Are those, yeah, because they're vertical angles. Absolutely, those are congruent because they're vertical angles. I agree with that. But are those the angles you want me to talk about? Are those the angles in the triangles? No. So which angle C's are you talking about? Which inside ones? I know. You guys are going to get very frustrated with me on this because I want you to name angles properly. We can say angle A because there's only one angle A. There's no other angle that has that vertex. We can say angle B because, again, there's no other angle that has that vertex. You cannot say angle C and then go, oh, well, Mr. Bobier, you know which one I'm talking about. Because I'm going to say every single day, nope, I don't. I have no clue which one you're talking about. And I will always point out the wrong one, by the way. If you're saying angle C and there's more than one angle C, I will always point out the wrong angle C. So you need to make sure to name it properly. How would we properly name that angle C that's inside the triangle on the left? Do you remember how to name angles? Using three letters, the vertex in the middle. Oh, angle ACB. Cool. That is going to be congruent to which other angle? ECD. These guys are congruent because they are vertical angles. So that's because of the vertical angles theorem. Questions on this example? Now, if they asked me to, well, actually, we haven't actually answered the question yet at all. They said, are the triangles congruent? Yes, they are congruent. Now, if they ask me to write a congruence statement, that's that roadmap, okay? First thing you got to know is that there is a symbol for triangles. Just like there's a symbol for angles, there's a symbol for line segments, all that kind of stuff. The symbol for triangles is a really hard one to remember. It's a triangle. Okay? So, we're talking about triangle something. We name a polygon according to its vertices, the corners, the angles. So how do you want to name that first triangle? Sure. So triangle ACB is then congruent to triangle. Now here we have to be careful. The first polygon, you can name it anything you want, okay, using those vertices. The second polygon has to correspond to the first. Okay, so angle A helps to go angle by angle. Angle A is congruent to angle E. And then angle C in the first triangle, so we're actually talking about angle ACB, is congruent to the angle C in the second triangle, angle ECD. And then angle B is congruent to angle D. Double check it with your line segments. Does line segment AB correspond to line segment DE in this roadmap? AB, DE, yeah, they correspond. BC correspond to CD, yep, they correspond. AC correspond to EC, those correspond. So that is an appropriate roadmap. Questions on this example? On the back side of your notes. First thing I'd like you guys to do, we're going to practice over here, making sure you understand what that roadmap is giving us. I'll do the first one with you. Looking at that roadmap given, line segment QX must be congruent to line segment NY. Don't forget to name it properly. Okay? And angle Y must be congruent to angle X. So, I want you guys to take the next minute and fill out the next 5 blanks. Ready, set, go. All right, Sierra, line segment TA, what's that congruent to? You're not Sierra.
RO.
Line segment RO. Could I have called that line segment OR? Absolutely. There's nothing wrong with that. Okay? Dakota, angle R is congruent to angle T. Very good. Make sure you put the angle symbol out in front. Wonderful. Let's see. Let's do Daniela. Angle U is congruent to angle A. Wonderful. Salali, line segment DB is congruent to
Line segment LK.
line segment LK. Absolutely. All right. And let's see. Lexi, NDBA. So they're talking about that entire quadrilateral is congruent to what? CKLU. Yes, and the way you did that, for those of you who maybe didn't know, looking at N sits right here. That corresponds to C, so that's what I have to list first. Then D corresponds to K, and you just keep going letter for letter, which angles correspond to which angles. Okay? Cool, very good. We then have a theorem. We have a theorem here. It's called the third angles theorem. The third angles theorem. And if we take a look here, the third angles theorem, we only use it for triangles. Okay? It's only for triangles. But in a triangle, or in two triangles actually, if we have two triangles and we know that two angles of one triangle are congruent to two angles of the second triangle. So for example here, angle B is congruent to angle E. We know that angle A is congruent to angle D. Then we would know that the third angles have to be congruent. That's what it's saying. Well, now let's think why. Well, what do the three interior angles of a triangle always add up to? 180 degrees. All the time, every triangle that exists adds up to 180 degrees. Okay? But if I look in here, and let's just say for the sake of argument that angle B was 60 degrees. Okay? And let's again say for the sake of argument that angle A is 90 degrees. So then what's the measure of angle E? Angle E. E. E is an ego. What? 60. 60 degrees. Yeah. What's the measure of angle D? 90 degrees. Okay, great. Well, what's the measure of angle C as in cookie now? 30. Has to, because it has to add up to 180, right? Yeah. So angle C has to be 30 degrees because those three angles have to add up to 180 degrees. Well, let's look at angle F. Again, those three angles have to add up to 180 degrees. Therefore, angle F has to measure 30 degrees. It's the only way it can happen. Well, look what ended up going on. Angle C is congruent to angle F. Okay? Those two angles end up being congruent, and it's because of the triangle angle sum theorem. So this is really a shortcut for that triangle angle sum theorem showing that our third angles are congruent. It is also handy because we can now say that we have congruent angles without knowing any angle measures. Okay, we don't need to know any angle measures, but I can still say that angle C is congruent to angle F. I know that information. Okay? Questions? No. Let's take a look at a proof then. Our good friend, the two-column proof. So, starting out with our two-column proof here. All right, so we have statements, reasons. Our first statement is always the what? The givens. And we have a lot of givens in this problem. So, line segment ML is congruent to line segment LO. We know line segment MN is congruent to line segment ON. We know angle M is congruent to angle O, and we know that angle MLN is congruent to angle OLN. All of that is given. Okay, so looking at our givens and all the givens are now marked in the diagram. So how many sets of corresponding parts should we end up with in this problem to show that the triangles are congruent? 6. Remember, 3 sides and 3 angles. How many sides do we currently have? 2. How many angles do we currently have? Bless you. How many angles do we currently have? We currently have 2 sets. 2 sets of angles, right? We're talking about the sets of angles. Bless you again. So, we need another pair of angles and another pair of sides to be congruent. Can anybody see how we would get another pair of angles or another pair of sides?
Well, I guess, but you could use the third angle theorem.
Okay.
And since you have 2 of the angles already, you could make it ONL is
Good job.
congruent to angle LNM.
Angle ONL is congruent to angle MNL. Either way. Okay, hold on. You already did one. All right. So, and be careful. You got to be careful how you name angles. Because remember, the letter in the middle is the vertex. And so a lot of times I hear students say, well, wait a minute, didn't we already name those? The answer is no. This up here, MLN, is not the same angle as MNL. They have a different vertex. MLN is this angle over here, MLN, this angle here, whereas MNL is this angle over there. Okay, so you got to be careful how you name these. But we do have that. We do know then that these angles are congruent. So we now have our 3 sets of angles. Good. We need another set of sides. We need another set of sides. Now, looking at what we already have, we already know that line segment ML is congruent to line segment LO. We already know that line segment MN is congruent to line segment ON. How am I going to say that I have another pair of sides that are congruent? Any ideas? First, what sides are congruent? Anybody even know that part? LN? Well, since there's only 3 sides to a triangle, it's a good bet that the third side of those triangles is the ones we're talking about. Okay? But now how do I know that they are going to be congruent to each other? Any ideas? Elijah, your eyes open? Any ideas on why line segment LN might be congruent to line segment LN?
Because the other 2 sides are already congruent to each other?
Nope.
No? Okay.
Are you the same size and shape as yourself?
Yeah,
Yeah. Why?
because they're symmetrical. Because
So why is line segment LN congruent to line segment LN?
Because if you fold it, it's exactly the same.
I don't have to fold it at all. Isn't it the same line segment?
Yeah.
It's the exact same line segment. It's not even on 2 different parts. It's not butted up against each other. It's the same thing. Right? We had a property about that where if you stand in front of a mirror, what's in the mirror is the same as what you are. Right? As far as image, right? What was that called? Yeah, the reflexive property of congruence. The reflexive property of congruence. Now we get to see where that actually gets used. Because I still have to name those third sides of the triangle. Well, in this case, it happens to be the exact same side. It just happens to be a side in both triangles, right? So I've got to state that line segment LN is congruent to line segment LN. So, we now have our 3 sets of angles and our 3 sets of sides, so we can now say that triangle LMN is congruent to triangle LON, and we're going to use that definition of congruent polygons from the front side of your notes. Okay? The definition of congruent polygons tells us that if all the corresponding parts are congruent, then the polygons are congruent. One more proof to do together. One more proof to do together. So taking a look here, we're going to get this proof started with a 2-column proof. Statement number 1, of course, is all of our givens, which again, there are a lot of them. Angle A is congruent to angle D. Line segment AE is congruent to line segment DC. Line segment EB is congruent to line segment CB. And line segment BA is congruent to line segment BD. All of that information is already marked in the diagram. Do we need another line segment? No, we already have all 3. We don't need another line segment. Do we need another angle? Yes. How many?
2.
We need 2 more sets of angles. So, I will leave it to you guys now to try to finish this proof. You should only need 3 more steps in this proof. Okay, you need to find 2 more sets of congruent angles. You should be able to get this entire proof done in 4 total steps. Okay, we'll be back. All right, so this is what we should have for our proof then. Any questions on this?